Hi, everybody. This is part two of the pre-recorded videos that I'm doing to make up for the fact that there's a public holiday on Monday. So this is part two. In part one, I did a lecture program that had a 2D array of structs in it. This time, I'm doing a recap of strings, talking about arrays of strings, command line arguments, and multi-file projects. As always, there's links to the live lecture code. This is the stuff I did in the previous video. So this is what we're doing now, strings. So in C, there's no keyword called string. So you don't do, like there's int, char, double, struct, enum. But for strings, we actually just store them as a collection of characters in an array. So in C, a string is an array of character, but it's not any array of characters. It has a special null terminator. So this null terminator indicates where the string ends. Okay, so anything before that is part of the string. And once we get to here, even if there's more space in the array, that's just considered to be garbage and not part of the string. Okay. So how can we initialize strings? So, yep, they're an array of char, and we can initialize them in a similar way to what we do arrays of ints. And this is a bit annoying to have to keep putting these single quotes and commas, and we manually have to, put this null terminator in. But it really sort of helps us understand how they're really stored. Now, we can also do this using the double quotes. So you've seen these double quotes before because you've been doing like printf and printing out strings. It's just that until we've done the string topic, we haven't been storing them in variables. But this, again, C will know, okay, this is an array of characters, and it'll go and set this up in exactly the same way, and it'll add this in without us having to explicitly tell it to this null terminator. So this is the convenient way that we'll do it. Okay. How can we print them out? Well, there's an easy way. We just use printf %s and pass in our string that we want to print out. But to understand what's going on, it's worth looking at this version here where we kind of do it ourselves. So here it's basically like just traversing an array. We start at index 0, except unlike with arrays of integers, we don't tend to keep track of how many characters there are in all of our strings, because all of our strings will typically have different numbers of characters in them. Like, you might want a string to represent somebody's name, and the name might be Tim versus a name that, is much longer. So instead of keeping track of the sizes of all of these strings, C decided, oh, we'll put this null terminator on. We don't have to have all these integer variables storing the different lengths. We'll know when we get to this character that that's the end of the string. So we're traversing an array, but we don't know how many times we want to increment I. We just want to keep going until we get to a piece of data or a character that equals this null terminator. So here we start at index 0 and we check, is the word at index 0, so is this equal to the null terminator? No, we print it out and we move on and print them all out one by one. When we get to here, yeah, word at index 5 is equal to the null terminator, so we'd stop. Okay, and occasionally you'll need to write code like this, not to just print out the string, but you sometimes might want to go and examine all the characters in a string to do something else. So it's good to see, and it really helps us understand the importance of this null terminator. If it's not there, printf %s or anything else that thinks this is a string is not going to know when to stop. And it's going to try and keep printing out characters and go beyond the end of your array and crash and, you know, whatever. Do things that are no good. So if we can do printf%s, can we do scanf%s? Yeah, there is such a thing, but you're not allowed to use it in this course. This is like a better, safer way to do things. We use fgets. So for fgets, we do need to tell fgets the array that we want to read the string into, and we tell it the size of that array. And then we tell it where we're reading this in from. And in this course, this is always going to be stdin, standard input, which by default is the terminal. So that's by default, it's just where you're typing into. So in this example, imagine we've got an array of max length 6, so the arrays of size 6. And imagine the user is typing in hi and then presses enter. So they've typed in H, I, they've pressed return, which is a new line, and fgets reads all that and puts it into the array, and fgets adds this in for us. Okay, obviously the user did not type that in. Fgets sticks it in there for us to mark the end of the string. And anything after that is just garbage, considered garbage. Now, if the user had typed in something else, not hi, but you know, extra characters, at some point, when it gets up to basically max length -1, fgets will realize, well, I can't fit any more data in here because I still have to make sure I've got this null terminator. So fgets is really good. It won't let a user it won't keep reading in data to overwrite the end of the array, which is good because that's a huge security risk. You know, it could at best kind of crash your program, at worst overwrite something else. And it also makes sure it doesn't fill it right up without having one of these null terminators. So fgets is really handy in that respect. We also looked at some other string.h library functions. So we had a look at these first three. Oops, oh, what am I doing? And we'll have a look at this one again today. We didn't look at these, but yeah, you might play around with them at some point. But there's a whole, if you go here, there's a whole heap of different string functions. But this is a really common one, string length, string compare and string copy. They're probably the most common and useful ones. All right, so let's do some coding. So in this one here, I've declared two strings, one called str, one called reverse s, and they're of length 100 actually, but let's forget about reverse s for now. But str, you know, we're going to have, I'm not going to draw this all in up to 100, but we're going to have indexes here all the way up to 99, right? It's of size 100. And right now, they've all just got, we haven't initialized it at all. So this all just has uninitialized garbage in there. If we tried to print it out, we'd get a runtime error. So what does this code do as it is? It's saying enter a string, and now it uses fgets, which we've just talked about. It's going to read it in to that string. And we can put fgets in a loop, and this is going to finish if the user just types in Control D. So if a user types in Control D, fgets returns null. And that can allow users to say, yeah, I've had enough, I want to stop. And fgets will tell us by returning null and our loop can stop. So here, all it's doing is printing out what we typed in. So I can enter dog, and it says you typed in dog. I can enter cat. Oh, and by the way, right now we've just entered dog. So dog, and we press new line. So that's what we've typed in. And then, fgets has added that null terminator. Okay, so when it's printing out, you typed in dog new line. That's why I've got that extra new line. Now, if I type in something else, like, I don't know, cake, it's going to overwrite what's in here already. So instead of, we've entered cake, it's going to have overwritten dog. Once I'm ready to finish, I just type Control D. And in this case, that ended the while loop, but it also ended the program. But in our program down here, our string would have had cake in it. That would have been the last thing in there. Now, what's common is sometimes we want to get rid of this new line character that we get with fgets. And a common way to do that is to think about where it's located. So we looked at a function called string length that can tell us the length of the string. The length of this string is 1, 2, 3, 4, 5. We don't include the null terminator. That's not part of what we want to print out or represent. So the string length is 1, 2, 3, 4, 5 in this situation. Where's the new line character? It's always, like with fgets, we're going to get this one new line character at the end. So if our string length is 5, our new line character will be at position 4. Or in other words, more generally, it will be at string length -1. So what we're going to do is we're going to try and get rid of it. So we're going to check, is this one here actually a new line? If it is, we want to get rid of it. And to get rid of it, we just actually turn that, we overwrite it and turn it into a null character. By putting this null character, it means this is where our string ends. We just end up with cake. So let's try this. I've got code down here. I've already written it. This prototype, well, we pass in our string. We're not giving it a size because the new line, the null terminator will be able to tell us everything we need. But anyway, we go and call the string length function. It's going to tell us the length of this string. Like I said, in this case, that would be 5. We go to index 4, like length -1, and check, is there a new line character? Yeah, there is. So we go and overwrite that. We go and put this null terminator in there. And now it doesn't matter how many of these null terminators we have. As soon as we have one, that's the end of our string. So our string would now, in this case, have cake in there. So up here, before we print out what was typed in, we can call this function and pass in our string, and then it's gone. And that's going to be really helpful for things like if we did want to do a string compare, did they type in cake? It'll be able to work out, yeah, it won't have this extra new line character messing things up. So basics. Let's just go back to dog. You typed in dog, and we don't have that extra new line now. Okay. Now, the next thing let's do a quick string compare. Let's check. Now, imagine I want us to see if somebody had typed in the word, yeah, why not cake? We're comparing the word cake to whatever the user types in, and string compare will return 0 if the strings are equal because there's no differences. So let's just have an if statement saying, hooray, there is cake. I don't know. That will do. Just as to remind us how we use string compare. So I'm typing in dog. It's not going to, hopefully it's compared it and it doesn't think that that's cake. But if I do type in cake, it's string compare will say, yeah, you did type in cake. Hooray, there's cake. Now, if we hadn't removed this trailing new line that fgets will give us, it's not going to recognize cake. So dog, yeah, of course, it's not going to think dog is cake. And we can see that new line is back. But even when I type in cake, it's not going to say it's equal to cake because really my string has cake new line, okay, which is not equal to cake. So just keep that in mind if you're doing string comparisons. Do you just have the same string, but it's got an extra new line character at the end? Yay. All right, now just for a bit of an exercise, we're going to write a function to check if our string just contains all lowercase characters. And yeah, we're going to call it all lowercase. And if indeed our string has only lowercase characters in it, it will return 1. It will return 0 otherwise. So if it equals 1, we say you have all lowercase characters. Okay. Oh yeah, so how do we actually write this? That would be good to know. Well, basically we want to look through all of our characters from beginning to end. So we need one of those types of while loops or for loops that starts at the beginning, and we don't know the size. We're going until we reach that null terminator. One by one. So, let me do a clear here. If I'm looking at this one, I'm going to look along and go, oh, yep, C, that's lowercase a, yep, K, E. I get to here and I stop. So I'm going to have a variable called all lower, and I'm going to assume, yeah, they are all lowercase letters. But if I find one that's not, I'll change my variable. So I'm going to check. I'm going to check each one is and I'll know that it's not lowercase. So lowercase letters are greater than or equal to A, and they're less than or equal to Z, right? The lowercase a and Z. So if I've got a character that isn't within that range, so it's less than A, or it's greater than Z, it's not between lowercase a and Z. It's not a lowercase letter. So as soon as I find one, oops, that's not a lowercase letter, I change that. All right. So this is just an example of a situation where you do need to go through all of the characters in a string one by one and do something. Let's just test this. Did I call it up here? Yeah. All right. So I'm just going to type in something like A, B, C, D, X, Y, Z. They're all lowercase characters. Great. What about though if I do, something like this? It's not telling me they're all lowercase. What about if I do something like this? Not lowercase. Not lowercase. Okay. Now that's not really thorough testing, but that'll do for now, given we're sort of in a recorded lecture. All right, now this example is a bit trickier. We're going to try and reverse a string. So imagine we've got our string, which we do have, and we're going to create a reverse of it. I'm just going to call this rev for now. And we don't want to reverse this. We need this null terminator to be at the end, but we want to reverse these other letters. So we're going to take the C, for example, we're going to start here. Oh, there's a C. We're going to put this here. Then we see that we've got an A here. We're going to put this here. We've got a K here. We're going to put this here. We've got an E here. We're going to put this here. And then we're going to end up with the string reversed. That's sort of the idea. So we kind of know how to do the first. Oh, and also, when we're running this, we're going to pass it in like this. Reverse. Oh, have I got? Oops, I'm spoiling it here. I'm passing in both arrays, the original array, and then the one that's going to have the reverse copy in. Okay. So up here, I'm calling the reverse function. I'm passing in, well, up here, I've got the string str, which is the string that, the user's just typed in. And I've got this other string that so far I haven't done anything with. It's just empty. I've been saving that to put the reverse in. Now, I've got to make sure that this string is big enough to fit the reverse of the other string. So I've made them both exactly the same size. And I've even made this function just assume that they are the same size. All right. Yeah, so the first part we kind of know how to do. We're just going through this string one by one until we get to this null terminator. So I started index 0, and I'm taking this C and I'm putting it in the other array. But where am I putting it? Where does this C go? Well, it's going to go here at index 3. But why is it going at index 3? Because the size of this string that I'm reversing is 1, 2, 3, 4. So the last letter will be at index 3. Okay, so I'm going to create another index called J, and that's going to start at the string length -1. So I'm starting with I is equal to 0, and J in this case is equal to 3. And I'm just saying, let's take the character from our original string at index I, and we're going to put that in our other string at index J. Okay, so we're going to the original string. We're taking this character C out at index, at this case, I is equal to 0. We're putting it into this other array at J is equal to 3. Okay, so we put the C in there, and the next time around, we want to put something in J is equal to 2, for example. So we need to decrement J. So next time around, J has been decremented, I has been incremented. So we'll be moving this A from index 1 in this string to index 2 here. then again, we will be incrementing I and decrementing J. So we take this one from this string at index I and copy it into this one, this string at index J. Then we have to, we keep going. We do this again. Oops, I is up to here, J is up to here, and we copy over this E character. Okay, so now we've gone, and at this point, when we increment I, and we go through this loop again, we see, oh yeah, this string at index 4 is equal to the null terminator, so we're going to stop. So at this point, we've copied all of these letters over. So let's see what happens if we try and run this. Let's compile it and let's run it. Looks good. Let's type in cake to do exactly the same thing. Oh. Let me just clear this. Sorry, I forgot to actually print it out. So we've got a reverse of the string. The original string is unchanged, but we want to see if our reverse worked. So we're going to print it out. Oh, and this doesn't look good, actually. We're printing it out, and it's actually saying uninitialized variable. What have we done wrong? Basically, even by looking here, we can see we've got all these letters, but we haven't put in this end of string. So when we're printing it out, it's looking for this end of string and it keeps going, trying to print more characters. So typically when you lose or you don't put one of these end of string terminators in there, this is what can happen, right? And this is what happens when you're playing around with individual characters yourself. You can destroy it. But in this case here, all we have to do is make sure at the end, well, where does this go? Well, this was string length -1 that had the first letter. So it'll be at string length. So if I say, let's go to my reverse string at where I know the string length of S. So I know that S was 4. The string length of S, sorry, it was 4. So I know its null terminator was at index 4. And I know that's where mine needs to be as well. Because we've got the same number of characters. It's just that these are reversed, but this should be in the same spot. Once we put this in, it should work. Oops. Let me try that again. I just typed in something weird. Let's type in cake. Yeah, and it's done it backwards and it hasn't crashed. If I type in cat, it should, let me get rid of all of this. Should do that backwards as well. Okay, so that was just a little bit more about strings. Oh, that's right. And in one of the examples I gave you, I kind of did something that wasn't so great. So we had this string, boots, which would look like this. I can't remember the max length, but there was extra room in here. So we had that, and then we were using string copy. So with string copy, this is the string we're copying it into. So this is our string here. We're copying it into this string. So we're actually overwriting what's already in there. What are we copying? We're copying Finn in. And Finn in our string, even though we're just hard coding this string, we've got F, I, N, N, null terminator. So we're copying it in, and string copy is doing this for us. And we're telling it the maximum length of this array, because this particular strncpy, it won't overfill our array. So anyway, so we're going to end up with F, we'll go over this letter, I, N, N, null terminator, and it worked, and we printed out fin. So in this example, what I had was fine. But yeah, I should tell you what I had. I had it like this, and this worked in this scenario, but in general, this isn't the safe way to do it. So the whole idea is, imagine, I mean, in this case, we know that fin is going to fit in here anyway, but just say we were copying some other string. I'll just call it S. And we didn't know the actual length of that yet. We hadn't worked it out. This might not have worked if this string was really long, because string copy won't leave a space for the null terminator like fgets does, and it won't put in the null terminator like fgets does. So you just got to be a little bit more careful. So in case, in a situation where this was a general string and it might be really long and we don't copy it all over, we want to make sure we cut it off at max length -1 so we can fit the null terminator in, and just append that null terminator in case. So in this example, yeah, if it's fin and we know it's going to fit, nah, but in the more general case, this is how you do it. So it's better to just always do it like this. Okay. All right, so I've done this example. Actually, I'm not doing this example. I think it's too tricky. I might give you the code for it that anyone who's interested can look at. Let's move on to arrays of strings. So yeah, I can have an array of strings, which is really cool. So I can initialize my array of strings, many strings. So in this case, I've got 3 strings, and they can have a maximum of 5 characters, but that includes the null terminator. So really I can store 4 characters in there, plus I need that extra space for the null terminator. Now I can think of this as a one-dimensional array of characters. So when I look at this, it looks like a one-dimensional array of characters. But I can see here it's declared, as a 2-dimensional array. Sorry. Gosh, it's getting noisy here. I should repeat that, because you can think of it as a one-dimensional array of strings. All right, I've got 3 strings. But I can also think of it as a 2-dimensional array of characters. So down here, I can think of it like this one-dimensional array of strings. At index 0, I've got hat. At index 1, I've got cake. At index 2, I've got tea. But it's also actually beneath the surface a 2-dimensional array of characters. And I've got 3 rows. And oh gosh, it's so noisy. Why do people have a life? Why are they going out on a long weekend at night? Why aren't they sitting at home like me? Okay, so but they're quite distracting. I've got 3 words. I will get this out eventually. So I've got row 0, row 1, row 2, and each of the strings is on a row. And then I've got 5 columns, column 0, 1, 2, 3, and 4. So each of my words can have a maximum of 5 characters, including this null terminator. Okay. All right. So if I use one index, I get a whole row. So if I go to words at index 1, I get this whole row which gives me a string. Whichever representation I'm looking at, I go to the one at index 1, I get the whole string. And I can do that and say print out, in this case, cake with %s. I could also choose to, look at this character by character. So if I give 2 indexes, I get an individual character. So here I'm saying row 2, which gives me this, row 2. But then I can go within that to character 1, the character at index 1. And I get this E character, this E character, this E character. It's all the same thing, but whichever way you're thinking about it, you're going to that next character in this string. All right. So now, all right. So now let's go to the coding example of the array of strings. All right. So here in this example, I've got the same strings basically, but my array's a bit bigger. I've got enough room for 20 strings, and I've got each of the strings can actually hold 10 characters, or 9 characters and the null terminator. All right, because I've initialized them, all of these have got, the hat, the cake, the tea. The rest will also be initialized to zeros, which for a character, they're like all initialized to the null terminators, right? All the ones that don't have data in them have a null terminator in them. If I'd done it like this, they'd all just have uninitialized garbage. Because I've done it like this, we've got hat, cake, tea, and just all the rest will be null terminators. Now, in this example, I've got room for 20 strings, but I'm only using 3 at this point. All right, and here's another example. If I go to my array of strings at index 2, what would I be getting? What am I doing? I better save it. Unused variable. I'll just ignore that for now. So yeah, if we go to the one at index 2 and just print out the whole string at index 2, we're going to get T because that's at index 2. If we go to index 1, 2, well, that is string number 1 at the index number 2 within it, 0, 1, 2, we should get the K. Or if you want to look at it up here where I've sort of really spelt it out and drawn it out, row 1, column 2 gives us the K, right? So however you need to think of it for a given situation, you can think of it as a character or a string. All right, now what if I just wanted to print all of them out? If I want to print all of them out, it's actually not that hard because I want to print them all out as strings. I want to print hat, cake, tea. I just think of it as a one-dimensional array of strings, and I can just start at, oops. Okay, and I just go one by one. I go from index 0, I print out hat. Index 1, I print out cake. Index 2, I print out tea. I don't want to keep going and print out all these empty strings. So I'm not going to go and print out 20 strings. I'm just going to print out the 3 that I'm interested in. All right. But anyway, however many this size is, that's what we're going to do. We're going to just print them all one by one. We're going to data at I. Okay, and we print it out like that. So when I call this, like I said, I don't want to print out all of the ones that I haven't really got any proper data in yet. I'm just going to print out text and however many strings I've actually got in there at the moment. All right, now if I compile this and run it, it should just print out hat, cake, tea. Okay. All right, now imagine I want to actually, I've already got hat, cake, and tea in there, but I want a user to be able to enter more data. So for example, I want the user to be able to enter data and write, you know, for lack of a good imagination, dog. And of course, if we get it entered by fgets, we're going to get this new line character. Okay. Oops. I've got to actually write the fgets though, don't I? So down here, I'm going to say fgets. Now, where am I reading this into? I'm reading it into this array, but not at the beginning. I've already got hat, cake, tea. I want to put this one in at index 3, right? 0, 1, 2, 3. Whatever the user types in, I want it to go text and index 3. That's sort of the chunk of memory for one string that is free right now. I'm going to put it in there. How big can my strings be? Well, I can have 20 strings, but they can all only be a length of 10 or max length. Where am I reading them in? Well, it's always standard input. Okay. All right. So I don't want to print them out again. So let's try that. All right, so it's printed out hat, cake, tea. Actually, let me just print this out to make it clearer. And actually, once we've entered that other string, oh goodness, I can't type. Once I've entered that other string, I've got an extra one. So I've got hat, cake, tea. I'm going to enter dog, enter the string dog, and I'm now going to have 4 strings, and I'm going to call the function to print those out. And of course, because I got my dog from fgets, I'm going to have a new line. We know how we could get rid of that if we wanted to. Okay. Alternatively, I could just forget all of this. I could just have an fgets loop that read in all the data myself. You can try that for fun. But yeah, I'll just leave it there. Just so you can see you can have an array of strings. All right. Sorry, I was so distracted with that and all the noise, my goodness. All right, next example, the next thing we're doing, what are command line arguments? So these are really cool. So far we've only given input to the program after we've started running it. So we run it, compile our program, whatever, but we run our program and then our program might get the user to enter data and we use scanf or fgets to read it in. And our main function prototype has always been int main void. Command line arguments allow us to give inputs to our program at the time we start running it. It allows us to feed in input into our main function. So if we have a look at this code here, so we can compile our program. Imagine we've got a program called prog.c. We're compiling it, and we're going to call it program. But even if we look here, this is a prime example of command line arguments. So the program we're running is DCC, but before we've even started running it, we're passing input or data into the program on the command line. This is a command line argument. So it's not like we're running DCC and then DCC is saying, please enter the name of the program you wish to compile, and then we're typing in prog.c, and then it's not saying, what do you want to call the executable? It's not doing that. We just can copy and paste this whole command and, we don't have to wait and then type in extra stuff once the program started running. So that can be really convenient. We can do that in our own programs as well. So if we've programmed our program for command line arguments, we can run our program and then enter extra stuff on the command line, and that can get fed into our main function. Okay, but to do that, we've got to use a different prototype for our main. So we've got to say, instead of int main void, we've got now parameters and inputs into our main. argc is just a counter, stands for argument counter. How many command line arguments are there? Then the command line arguments themselves are passed in as strings. And for now, we can think of this as just an array of strings. Okay, an array of strings, and we've just seen how we can sort of use those. All right. So imagine I have programmed command line arguments into my code. I'm not using int main void. I've got int main argc char star argv blah blah. I can run my program like this, and my argv would actually be 4. So 1, 2, 3. If you want to pass in like something with spaces, you have to put quotes around it. Anyway, so we'd have 1, 2, 3, 4 command line arguments. So argc would be equal to 4. We'd have argv that would contain all of these as strings. So even though we're typing in 123, it's not the number 123, it's the string 123. And these would be at indexes 0, 1, 2, 3, etc. So just an array of strings. All right, so, typically in your program, you might check what some of these are equal to. You might have you might run your program in slightly different ways depending on these options that you're given. Here, we're just sort of showing you how they work. Let me go to code and show you this program. All right, so first of all, we're printing out the number of command line arguments, which we know we get from argc. Then we're printing out argv at index 0, and we know that's going to be just the program name. So actually, let's go back to here. The program name itself is included in the command line arguments, and it's always at index 0. Okay. And then we're just going through all the command line arguments. So we know how many entries there are in our array. That's argc tells us that. And we just go to argv at index, whatever index we're up to, and we've got a string. We can print it out. So if I run this, I could type in command line arguments like this. Okay, and it's telling me there are 4 command line arguments. The program name is this. Yes, that's correct. The argument at index 0 is this. Yes. Argument at index 1, 2, and 3. Yeah, and if I did something like this, there's spaces, right? The arguments are separated by spaces. The hello and the world would be considered as two different arguments. If I wanted to make them one argument, I'd just put these string around, right? Okay, and they're not given in as part of the string. They're just telling Linux that that is one argument to send into my program. All right, now what if I wanted to take in numbers? Like I wanted to write a program that, for whatever reason, went through and summed all of the arguments. So if my program's name was A to I demo, 91, 5, it could add up all of that and give us 90 plus 1 plus 5, 96. And imagine I wrote my program like this. I've got a sum, which is equal to 0, and I know that the one at argv index 0, I know that's going to be my program name. So I'm not going to do that, but I'm going to start at index 1, and I'm going to get this value, then this value, then this value, up to however many values there are. argc will tell me that. I'm going to add it onto my sum. So I try and compile this, but it's not going to work. It's saying incompatible pointer to integer conversion, assigning to int from char, blah, blah. Now, what's the problem? The problem is all of these arguments, they're not integers, they're strings. So if I've got, say, the command line argument 90, it's the string 90, the string 1, the string 5. And as we've just seen, like, that's really an array of characters, like 5 and then a \0. And this would be an array of characters 9, 0, like this. We can't just do maths on these things if they're strings. They're not the same as integers. So we want to be able to convert these string versions of our numbers into integers. And there's a function that allows us to do that. So I can use A to I. And for example, I could pass in A to I and it's going to give me the actual integer 1, 2, 3, for example. So I get passed in all my things as strings. A to I will convert them into integers. So when I do it like this, I can do 90 plus 1 plus 5, and I get 96. Now, what if whoever's typing in types in rubbish? I don't know. Actually, it's quiet now. You'll be glad to know. It just includes that as 0. All right. So yeah, A to I, really handy. We definitely use it a lot with command line arguments if we want to convert things to integers, but we can use it other times as well. Right. Just more examples. Okay, so I've shown you all of that. Last thing in this lecture is multi-file projects. All right. So far, everything we've done has just been in one C file. And that's been fine for what we've been doing. Once you're writing bigger programs and once you're working with teams, you often want to spread out your programs over multiple files to help to improve readability, to separate code, put related code into different files, in a modular way. We could even call them modules and we could test and write them separately. And we've been using this multi-file capability already because we're hash including .h files, and the .c code for those is getting linked in with our code when we compile it. The compiler does all that for us. But we've only been doing that with the official kind of libraries. We can also hash include our own. So this allows us to join projects together. It allows us to, like if we're working in a team, work on different parts at the same time and put them all together. It also means we can create sort of libraries of code that we could reuse again ourselves. And just before you get too excited, we can't do this for assignment 1. Assignment 1, we need you to leave that in one file. Don't split it up. Assignment 2 will be split up into multiple files. You'll hear more about that then, and we'll be doing it in a lab as well. So in a multi-file project, you typically have multiple .h files, right? .header files, similar to what you've been including from the standard libraries. And then you'll have the implementation files, the .c files that actually implement all of the functions that, you know, are defined in the .h files. Then you'll have one C file that has a main function in it. So every program will have just one and only one main function. And, you know, the idea is we write as little code in that function as possible. Anyway, so header files typically contain function prototypes, comments. They might have some hash defines, enums. They might even have some structs. They don't actually contain executable code, like, you know, while loops, x equals x plus 1. They don't typically contain anything like that. The .h files give the programmer all the information they need to use the code, you know, just like we say prototypes do. And then also the compiler. So when you include a .h file, that has enough information to let the compiler know whether you're using all that stuff properly and whether your code makes sense. Okay. So yeah, there'll be exactly one C file with a main function. The other C files will contain implementations of functions that you defined in the corresponding header files. So the .c files will include the relevant .h files. The other thing is you'll use quotes instead of the arrows to include them as well. But let's have a look at this example. I've created an array utilities sort of module. So I've got an array utilities.h file, an array utilities.c file, and then I've got a program that uses the array utilities.h. And I've just gone and grabbed these functions that we'd written already in a lecture for arrays, and I just have packaged them up, you know, in this different kind of way. So let's go and have a look at that. Multi files. And I'll just get rid of some of these. All right, so first up, I've got this array utilities.h file. And here I've got all these different prototypes of things that might be useful if you're working with arrays of integers. I've got a function prototype that can print out the array, print out odd data, read data in, find the maximum, you know, and you could have more stuff in here that you've written that you think, okay, this would be great if I'm working with arrays again. I don't have to keep rewriting this code. And so here we've just got the prototypes. In a sort of other, you know, in another example, maybe there might be appropriate hash defines or maybe even structs or enums. In this example, I don't have those. Over here, I've actually got the C code. So this is the C code that implements these functions. So I've got the code for print data, print odd data, etc. And I've also included, so this is like having the prototypes at the top. Instead of having the prototypes at the top, I've included all of these. And notice when I include like an official library.h file, I use those arrows, greater than and less than. When it's my own, I use the quotes. Then I've got, and notice there's no main in here. These are just functions that are kind of like helpful to use. Over here, I'm hash including my array utilities.h because, again, this is like having the prototypes up here. And I don't have to code all this up. I can just like reuse this code, or even if I've just written it, it's packaged up nicely in a module, and I can focus on doing whatever task it is that's using these functions in here. In this example, it's a pretty trivial task that's not really doing anything that interesting. But I've put this all together. How can I compile it and run it? Well, I'm going to be compiling it together and calling the executable program. And I've got to compile all the relevant C code. So I've got program.c and arrayutilities.c. That's all stuff that has to be compiled and sort of linked together into one executable program. So let's do that. Then I can run it. And yeah, it works. So what you've got to remember is we need all of the C code. So if just say I only put program.c in there, it's going to try and compile it, but then it's going to say, hang on, there's no code for read data or print data or find maximum. All right, you've got to compile all of the C code. And, you know, if you just had these array utilities and just tried to compile those, it'd be saying you don't have a main function. So you've got to put all of the C files and compile them all. What you don't do is you don't hash include the C files. So you hash include the .h files, you compile the .c files. All right, but that's pretty much it. And you could have lots of these .h files and .c files. You might have a module that works with, I don't know, strings or something like that. And if you were part of a team, you could have people working on these different modules and then coming together to put it all together. All right, so that's really all we're going to say about multi-file programs. So that's it. Thank you for watching this. You can give me feedback, please. Yeah, and I hope that you are enjoying your long weekend, or you did enjoy it whenever you're watching this. And yeah, I'll see you in lectures on Thursday. We're going to be doing pointers. Okay. All right, cool.